Hi, and welcome to the Intro to Programming workshop, brought to you by the Academic Resource Center. Here are some of the takeaways and contents that we're going to be going over. So first of all, we've got the programmer's toolbox. So things like variables, operators, conditionals, loops, functions, and comments. We're also going to go over pseudocode. What is it, and what's the process in doing it? We're going to go over some fantastic errors and how you can possibly fix them, so interpreting the error messages and debugging some of those errors. And then we also presented a couple exercises. Since this is a recording, we don't actually have anybody here to do the exercises with us, so we'll just go over them and the concepts that they're meant to introduce. And then we're going to end with a little bit of advice. Building blocks. So one of the main basic building blocks are variables. Variables store values in a certain location that you can name whatever you want. So I've got 4 different languages here: Python, C++, C#, and MATLAB. All of them are commented in their respective language, and I've tried to color them in a way that is relatively consistent and meaningful. On the top, you can see a variable declared to hold an integer being a number that has no decimal. As you can see, they all involve putting a name with it. In this case, the name is answer. Now we have a way to declare decimals. In Python, you just put the decimal. In the C++ and C# languages, you need to specify that it is what's called a floating point number, or a float. And in C# you do have one extra little restriction in that you need to put an F at the end of the number to specify it. Otherwise, it's a different number. That's not too important. And MATLAB is much like Python. And you'll see this consistently throughout this whole thing. We also have string variables. So string variables hold strings of characters. So those are going to be words, numbers, anything that's in quotation marks, what I have colored orange, are what are considered strings. Right? And then lastly, we have a concept of a list of things, or an array. You'll hear it be called different things. In MATLAB, it's a matrix. That is basically just a bunch of variables put together in one. The next main building block we have are conditionals. Conditionals are just how you ask questions. So in all of these, you'll see it follows this sort of if, an else, and an if-else sort of flow. So your if statements are just one question and then what to do if that statement is true. So if value, and then the double equal sign means equal to 42. So if the variable called value has a value that is equal to 42, then the code that is indented in the if statement will run, which is basically just going to print to the console the word correct. The next thing that we have are if-else statements. So if the value wasn't 42, then you want to say something else. So the if statement is going to be the same at the very beginning. You're asking if the value is equal to 42. If it is, then you are going to print out the word correct. Right? Then you have your else statement. So else is what happens if that question wasn't true. So if value was not 42, then we will be printing the words try again to the console. Right. Now we can chain those multiple times in a row to get a whole array of options. So here we're just going to do it one more time, but you can have if, else if, else if, else if, else, and have as many of those else ifs as you could possibly want. So here, if value is 42, we are going to print correct. if value is greater than 45, we're going to print out the words too far, try again. And if neither of those are true, then we're just going to print try again anyways. Right? And then the last sort of concept that we can do with this is what's called nesting. That's where an if statement is inside of another if statement. Next up, we have loops. So loops are a way to just do code multiple times over without needing to copy and paste that code 20 times. That's the whole concept of a loop, just being able to loop back and do things again. So at the very top here, we have a for loop. A lot of the times in the C-based languages, you have a format of for int I equals 0, I is less than some value, I++. Really, that is 3 statements hidden in one. So int I equals 0 means create a variable called I and set it equal to 0. It doesn't have to be called I, but that's just a common one that is used. So after we create I and we set it equal to 0, we have what's called the condition. So this is essentially a little if statement. It's just checking, hey, is I less than 10? If that's true, the loop is going to keep going. The moment that that is false, the loop stops, and we go to the code that's after the loop. Right. And then the last statement is the incrementer. So that's what happens after the loop is run before the next condition is checked. The I++ is shorthand for saying I is equal to I plus 1. We're adding 1 to the number. It's incrementing it by 1. So really what this for loop ends up doing is starting at 0, and I is going to get a value of 0, 1, 2, 3, all the way up to just before 10. Right, now, similarly, and actually slightly more easier, are while loops. The reason why they're easier is because a for loop is really just a while loop that has an index that controls it, the number that controls how long it's going to be looping for. So really the while loop just runs while its condition is true. And commonly that's going to lead to a lot of infinite loops, but that's trial by fire that you just kind of have to experience. In the code that I provided here is actually going to do the exact same thing as the for loop above. There is no difference in their outputs. Looking at the C++, you can see that first line is the int I equals 0. Right? Then it's while I is less than 10. The next statement, I is being printed out to the console. The line below that is I++, which increments I by 1. All right, now we have what's called a do-while loop. A do-while loop, while not being in Python or MATLAB, can be done with a little bit of trickery. But in most of the C-based languages, you'll see it present. The do-while loop is just a while loop that's flipped on its head. Right? So for the while loop, you check the condition and run the code if it's true. The do-while loop runs the code and then checks the condition to see if it should loop. It sounds like it does the same thing, but what's important is the do-while loop, the code will always run at least once because it reaches the do and it runs all the code in that do section and then checks the condition whether it should loop or not. While the while loop, it checks the condition first, so if that condition starts off being false, none of the code ever gets run and it just skips over the loop. And lastly, we have what's called a for each loop. In Python, pretty much every for loop is a for each loop. MATLAB is pretty similar, but in the C-based languages, it's a slightly different concept where rather than needing to specify like a variable and a condition and an incrementer, it's going to take an array or a list of some kind and go over every single individual value itself. So in this case, it will go over the numbers 1 through 4. All right, now, one of the building blocks that you're going to be seeing are functions. Now, a function is a way of wrapping a little bit of code that can be used in different ways. So in this case, we created a little function that squares a number. Many languages don't have like a way to do exponents on numbers. So it gets sort of tedious, and sometimes you have to just make a function that will exponentiate values. And that's what we did here. We didn't have to. Squaring is really not that bad, but it gets this sort of idea of we want something that we can reuse, so I don't have to write as much code every single time I want to solve a problem. So we package the square function, and later on in our code, we just need to call it and give it a value that it can square and return. They all follow a very similar structure where you start off by declaring the function itself, basically saying, hey, this function exists, this is what its name is, and this is the variable that it takes. Some languages want you to specify what is returned. So in C# and C++, you can see at the beginning, it says int. That means that the function is going to be returning an integer variable or value. Right, then you have square, which is the name of the function. So that's what you would call later on. And then in parentheses, you specify what are called the parameters. So those are the values that you give the function that it's going to be able to work with. In Python, you see an arrow with an int there. That is just where Python specifies its return type instead of at the beginning. And in most of the languages, you're going to see a return statement, which basically says, this is the value that the function ends up returning once it's done. And on that, we can go on to comments. Now, comments are very important. It is a chore to do, but it's extremely important not only for other people, but for yourself. I have no idea how many times I've done a little bit of code. I left or just went to bed, and I woke up the next morning and I look at it, and I have no idea what it does. I have no idea why I did what I did, and it made no sense. That's why comments are extremely important, right? Because other people, they're not you. So it's good to leave a little bit of comments in your code specifying what's happening. And we'll see an example of bad comments later on. Now, a lot of languages have two different kinds of concepts. We've got single line comments and multi-line comments or block comments. The single line comments are, of course, just comments on a single line. So in Python, you use the hash symbol. In a lot of the C-based languages, you use 2 slashes, and then MATLAB uses %signs. So when you put that symbol in your code, anything that comes after it is ignored in the terms of like programming sense, right? So no variables are going to be declared, nothing's going to happen. It's purely for you to read. Now, we also have this concept of a block comment. So a lot of the times, a comment can't really fit on one line. So usually you'll have to do multiple comments in a row, and to avoid needing to do that and to have all the slashes taking things up, you just specify that, hey, these next couple of lines are all going to be code. Starting from, in Python, it's just going to be these 3 quotation marks. that's going to say where it begins, and the very next 3 quotation marks in a row specify where it ends. In the C-based languages, it's going to be a slash asterisk, and then an asterisk slash to say that you're done. And in MATLAB, you've got your %sign with curly brackets. All right, so why do we comment? Well, here's a great example of bad comments. Right, so this is what's called the fast inverse square root function. It's basically just a fast way of calculating 1 over the square root of some number. Now, they do this in a very interesting and unique way that manipulates the actual binary representation of the numbers, there's a whole series of videos on it on the internet, so feel free to look that up. But what I mostly want to focus on are the comments that were left, because, I mean, look at this thing. I don't know what this does. Like, I can tell you what the operations are, what's happening, but I can't tell you what this is supposed to be doing. Right, so they started off okay, saying evil floating point bit hacking. Bit hacking is just a fancy way of saying that they're messing with the binary representation of a number. But then they just sort of, I don't know, throw their hands up and stop. And then they start saying first iteration, second iteration, but iteration of what? This is why we comment code, right? It's a very clever bit of code. You can tell that the person who did it is extremely smart by being able to even figure out that that calculates 1 over the square root of a number. But you look at the code and it is just meaningless. All right. So this is another sort of situation where pseudocode can help. Now, what is pseudocode? Pseudo meaning false and code meaning code. So it's literally false code. It's just basically plain English, and it's meant to be a sort of high-level overview of what's happening. So it's made to be readable, and it has no set syntax. And that's really important. So there are no good set rules on how to make pseudocode because it's meant to just be something readable, sort of like writing a little note about it. So in this example, we have if input number is greater than 0, then print positive input. Else, if the input is less than 0, print negative input. Else, then print input is 0. And then you end your if statement. Right, so that sort of concept can be translated directly into pretty much any programming language. And if we go back quickly to our conditionals, that's just your if-else statement. And as you can see, again, they follow the same structure. So pseudocode is meant to capture the structure of it while ignoring the slight grammatical differences, which is called syntax. Right. So how do you make pseudocode? Well, you first just start writing comments to describe ideas. You start with the highest level ideas and start breaking it down into smaller pieces. And then you just repeat the process. Right? And you just need to stop when the pieces themselves correspond directly to the building blocks. So when it becomes something that you can pretty much just type directly as you say it, then you're at the level that you need to be with your pseudocode. Right? And from there, you just need to fill in the actual code and then just keep your pseudocode as the comments. Right? So you just coded and commented your own code. All right. So here's one of the, I don't know, it's a great thing and also a very upsetting thing that has to do with programming and its errors. You will get so many errors, but you sometimes get some really interesting ones. So they all come with an anatomy, and it's usually dependent on the sort of language that you get it from. Now, I've got two different language error messages here presented. We've got Python on the top and C# on the bottom. Some languages provide more information, some provide less. The error messages pretty much always will include where they occurred, and sometimes will even return the code which was being executed when the error occurred. So Python up here, it says the file maximum.py at line 5, and then it gives you what line of code that was, for n in numbers. And then the next line down, it's pointing to it with a caret symbol, and then it tells you what the error is. It's a syntax error, so something in the grammar, and it says invalid syntax. So you messed up on your grammar somewhere. In this case, I believe that it was missing a colon at the end. For C#, it says a compilation error, line 36, column 71, which basically means character 71. And then it says method must have a return type. So a method is just a fancy way of saying function, and a return type is the type that is returned from that function. If we take a look at C#, the integer at the beginning is the return type, saying what the function should be returning, in this case, an integer of some kind. Right, so we are probably missing that, or there is some typo that is making the computer not notice that it has a return type. Right, so say you were trying to find the square root of a number, and halfway through you got up, went to get a drink or something, you came back and thought that you were doing squaring a number instead of doing the square root. So you return the number being squared. Well, that doesn't actually throw an error. The program doesn't know that you meant to square root it. So what happens when your code's just not doing what you want it to? And this is where comments are very important, because you're going to need to look back through your code and understand what's happening at each step to see if you missed a parentheses or didn't subtract a number somewhere. You also need to create little small proofs of concept, right? So you don't need to work in the code itself that's having the problem. You can take little bits of it out onto a different area and compile that all on its own and test the code individually. And you can also include like little print statements throughout your code. So, I don't know, every couple of lines, print out the current value and see, is this what I expect it to be? And that's going to let you isolate that sort of problem, narrow down where exactly it's happening, and fix it. You can also do logical step-throughs. So that's just going line by line and in your head thinking, what is this line doing? And where is the value currently at? Is this what I expect? And sort of an offshoot of that is rubber duck debugging. So rubber duck debugging is a really interesting sort of concept to look into. It boils down to having a rubber duck on your desk as something that you can speak to and explain your code to. Because sometimes explaining something out loud lets you see the error faster than just reading it in your head. And that concludes a lot of the substance of the presentation. Now we've got some exercises. If you are interested in doing any of these exercises, feel free to pause and try ahead. I will give a couple seconds for that. The sort of exercises we're going to be going over are converting a temperature from Celsius to Fahrenheit. We're going to be finding the maximum value in a list of numbers. We're going to be summing all of the numbers from 1 to 100. you can determine if a number is even or odd. And then we've got the FizzBuzz program, basically outputting all the numbers from 1 to 100. And for multiples of 3, you output fizz. For multiples of 5, you output buzz. And for multiples of both 3 and 5, you print FizzBuzz. And lastly, output all of the primes that are less than 100. Now, a lot of these exercises are going to be relatively complex, but that's okay. It's meant to have you sort of think through the concepts, sort of learn, okay, what do I need to know to be able to solve these things? For our first exercise, we have temperature. Now, I believe that this says Fahrenheit convert to Celsius, but on the other side it says Celsius to Fahrenheit, but really it's just numbers to numbers. So whichever way you prefer, as long as you can double check and make sure. So given the numbers 64, 70, 215, and 32 in Fahrenheit, what is their corresponding temperatures in Celsius? Sort of ideas and concepts that I want you to be thinking about are, how do you convert a temperature to another one? How can you write that in code? And then how would you abstract this to be used for any temperature? And so the answer to the first question, how do you convert from one temperature to another? Most people don't have them memorized. I believe it involves like multiplying by 9/5 and either adding or subtracting 32. Forget which way it's for, but generally that's that. And actually in the example, let's see. Yep, so multiplying by 9/5, adding 32. Awesome. So that goes from Celsius to Fahrenheit. And then writing that in code, well, as you can see on this slide, I created a variable called 9/5, set equal to 9 divided by 5. Actually, I think this is supposed to be C#, so I should have included decimals for my numbers there. But anyways, I took the 9/5 and I multiplied it by the temperature in Celsius in the parentheses, and then I added 32. Now, to answer the last question, how do you abstract this sequence of code to be used for any temperature? The answer is you make it a function. Right, so now I can call my function, I call temperature, give it a temperature in degrees Celsius, and it will print out the temperature in Fahrenheit. So it's not entirely useful, just prints things out. You could make it return the value instead, and now you have a function that can just immediately convert your temperatures. For our next example that we were going to go over is maximum. So here's a list, and I want you to find the maximum value in that list. So the sort of questions I want you to be thinking about for this one are, how do you know that that number is the largest? Right, so if you look through, what's the biggest number? To me, it looks like 97. Right? So how do you know it's the largest? Well, the answer is I looked at all the other numbers, right? Well, how did you go about finding that number? Like, what was your thought process? Okay, I started at the beginning and I looked at the number and I was like, oh, 95 is pretty big. Is there a number bigger than 95? And I looked through. Yeah, 97 near the end. So 97, I think, is the biggest one. It's the biggest I saw. So if you can only look at a single number at a time, how would you find the maximum? The answer is it's actually almost exactly like what I just did there. It's just that you can only look at one number at a time. Now, how do you put all of these ideas together? Well, the answer is we take our list that we have, and I'm going to create a variable called maximum. I'm going to set it to a very small number. In this case, the smallest possible number, which is int.min value. You technically don't need to do that. You could have set it to 0, and that would have worked just fine. But anyways, I did a for loop, and I will get each different value using array indexing, which is taking the variable values, putting square brackets, and then putting a number in the square brackets to specify which value I want. So if I did values square brackets 0, I would get the very first item, which is 95. If I did 1 in those square brackets, I would get 47, and so on. And then what I did was I just checked if the value at that index is greater than my current maximum value, then I just say maximum is equal to that value I just got. So I'm going to store the biggest value I've found so far, look at and compare it to the next number. If I find a number bigger, then I replace it. And then I just go through every single number in the list. And once I'm done with that, I have found the maximum value, and I can print it out. All right, FizzBuzz. Basically, it just wants you to write a program that prints the numbers from 1 to 100. But for anything that's a multiple of 3, so 3, 6, 9, 12, any of those numbers, you want to print fizz. And if you have a multiple of 5, you print the word buzz instead of the number. For numbers which are a multiple of both 3 and 5, so think 15, for example, then you would print the word FizzBuzz instead of the number. Every other number will stay the same. So we've got a couple different questions. How do we get all of the numbers from 1 to 100? What does it mean for a number to be divisible by 5, or by 3, or by any other number, really? And how can we change the behavior of the program for different cases? Lastly, how can we put these ideas together for an actual program? So we've got two different solutions that I provided. One which is a more standard and typical approach that you will find. The other one is a more condensed and simple version that I wrote when I solved the problem forever ago. So I created a function called FizzBuzz that let me call it. And I used a for loop to start counting from 0 to 100. For any number that was a multiple of 3, I stored either true or false. And the way that I found that it was a multiple is I use what's called the remainder operator. Now, sometimes you'll hear this be called the modulo operator, but it's not actually doing a modulus. It's doing something slightly different, but unless you're working with negative numbers, you won't know the difference. So what the remainder operator does is it will divide the number that you have by the number that you give it. And instead of returning what that fraction is, it returns what's left over, or the remainder. So if we did 7 modulo 3, 3 can fit into 7 twice with the value of 6, and there's 1 left over. So 7 modulo 3 is 1. Now, if you have a number that is evenly divisible by 3, so like 9, 9 modulo 3, 3 can go into 9 3 times and there is no remainder. So it's 0. And so what I end up doing is I just say, okay, the modulus, or the remainder of whatever index we're at with 3, if that's equal to 0, basically asking, is it factorable by 3, then store the value. And I do the same thing for 5. Then I just create my if statement saying, if it's a multiple of 3 and a multiple of 5, I'm going to print the word FizzBuzz. Otherwise, if it's just a multiple of 3, I'm going to print the word fizz. If it's just a multiple of 5, I'm going to print the word buzz. And in any other case, I'm just going to print the number itself. For my slightly more odd solution, I did a very similar thing at the beginning, but I created a string that I called output. in the case of the number being divisible by 3, I added the word fizz to my output string. If it's divisible by 5, I add the word buzz. And so completely independently, if it's both 3, a multiple of 3 and a multiple of 5, the word fizzbuzz will be added to the string. So that's emergent just because of how I set up my if statements. And then the last thing I needed to do was check, is my string empty still? If it's empty, I'm just going to print the number because that means I didn't do anything that added fizz. I didn't do anything that added buzz. So I just need to print the number. Otherwise, I'm going to print my output string that I created. All right, now we have primes. So create a program that outputs all of the prime numbers less than 100. So how do we get all of the numbers from 1 to 100? What does it mean for a number to be prime? And so an example for that is 27 prime? Well, how do you know whether it is or isn't? Is 13 prime? Yes, no? So what finding the primes boils down to is the naive approach is just going over every single number and checking all numbers less than it and see if that number can divide into it. So if we started at 25, you start going every number below that. So 24, 23, 22, 21, and so on. You keep taking 25 and dividing it by each one of those numbers. And you see, is it divisible evenly by that? If it is, then it's not prime. And you stop at that point. And if you didn't find any, that means it is prime. So print out that you have a prime. And now we have parity. For parity, it asks you to create a program that lets you input a number, and it will print whether that number is even or odd. So how do you get input from a user? And how does the user know that you are actually expecting input? Right? Because if you are just waiting for input from the user, but you never said anything, that's like me sitting here expecting you to answer, but I never asked you a question. It just doesn't make sense. Now, what does it mean for a number to be even? Is 5 even? Is 8 even? What about 2.2? Is that even? Is 0 even? Right? These are all tough questions. Maybe not the 5 and the 8 necessarily, but it shows that there's more to think about than sort of what's just on the surface. And what I ended up sticking with is that a number is even if the remainder with 2 gives you 0. And so I took a number called input, and I did the modulo operator with 2, and I asked, is that equal to 0? And then for my if statement, I just asked, is it even, is it odd? And I printed the value is, and then the respective parity. And that concludes all of the exercises that we have. We have a little bit of additional practice. So learning by doing is a great way to learn programming. Right? I get asked all the time, how do I become a better programmer? And really, it's just, you gotta find a topic that you're interested in and pursue it. So if that's machine learning, go try and learn how to build an AI. Right? If you're interested in computer graphics, that's another fantastic area to get into with programming. And especially if you're into video game design, which I do think I also listed. You have robotics as well. Robotics is a really fun one and can lead to some really great jobs in engineering. And computer simulations, so like fluid simulations, those are really interesting. You also have stuff like web programming or web design, where you're building actual websites. And just mathematics in general. Programming is fantastic for handling mathematics problems. And I believe that that wraps up my presentation. I hope you learned something new, and I hope you have a wonderful day.